Boys and girls, today we are going to be on lesson 2 in chapter 2, estimating sums and differences. If you have your book, you can find more information than what I'm going over on page 64, and that is a really good reference for you as you go through this chapter. We're going to hop right into the main idea today, and we'll be estimating sums and differences by rounding and using compatible numbers. Our vocabulary will be estimate, compatible numbers. So, for an example, they ask us to estimate 923 minus 415 by rounding. And when we're talking about rounding, one of the things that I like to share with my friends is to think of it as front-end estimating. So in this case, you're looking at the digit in the greatest place value, 923. I would round that to 900, just reviewing the lesson that you talked about previously. Remember, the 9 is in the greatest place value. You look to the right of that, there's a 2, so it would stay the same. 415, the 4 is in the greatest place value. You look to the right of that, there's a 1. So this would stay the same as 400, and then it becomes a simple mental math problem of 9 minus 4, which is 5, so it would be 500. They're going to walk you through the steps. Some of the steps will be very similar to what we just talked about. So round each number to the nearest 100 and then subtract. So we rounded 923 to 900. 415, we rounded that to 400. And then it becomes a simple subtraction problem. 900 minus 400 is 500. So we use rounding to check, to make sure that the answers, when we actually calculate the problem, are reasonable. So our actual answer would be very close to 500. They ask us to estimate 812 minus 376. Again, we're going to look at the digit in the greatest place value. So you look at the 8. And you know that 1 is less than 5, so you would round 812 to 800, and then 376, the 3 is in the greatest place value. You look to the right of that, it's greater than 5, so you would round up to 400. So again, it becomes an easy mental math problem. 8 minus 4 is 4, so your answer should be right around 400 when you'd actually calculate that problem. Now, when you think about the word compatible, if you are compatible with something, with someone, you get along really well with them. You work well together. The same thing goes for compatible numbers. Those are numbers that when we want to manipulate them, when we want to add, subtract, multiply, divide, those are numbers that we can think through and be able to solve the actual problem mentally because we're so familiar with those numbers and they work nicely together. In this example, Garrett's cat weighs 9 3/10 pounds. Dieter's dog weighs 28 9/10 pounds. Use compatible numbers to estimate the difference. Sometimes compatible numbers are the same as those that you would estimate. So in this case, we would take 9 3/10 and think to ourselves, they're going to start with 28 because we're subtracting the larger number, excuse me. So they're going to take 28 9/10 and round that to 30, or use that as a compatible number. And then if we were rounding 9 3/10 to the nearest whole number, sometimes we would say 9, but because we're using compatible numbers, it's easier to think through the problem if we rounded it to 10. So we would say 30 minus 10, and that would be 20, because like 10s, 5s, 25, those are all numbers that we're super familiar with, and they work well together. So the difference is about 20 pounds. If we were to use compatible numbers to estimate the difference of 89 3/10 minus 52 2/10, you would look at 89 3/10 and think, 90 would be a super easy number to work with. And 52 and 2/10, I would say, oh, 50 is another easy problem, or easy number to think through in our minds. So then the problem 90 minus 50, 9 minus 5 is 4. So using compatible numbers, 90 minus 50 would be 40. Here we're going to talk about rounding with decimals. Kareem wants to buy a baseball mitt that costs $13.95 and a baseball that costs $8.47. Estimate the cost of the two items. We know that we're going to add those two together, so we're going to estimate the cost of the two items. If we take $13.95, there's a couple of different ways we can manipulate this problem. We could round to the nearest 10, okay, and if we were going to round $13.95 to the nearest 10, we know that it's between 10 and 20, but it's actually closer to 10. Okay? Same thing goes for $8.47. If we were going to round that to the nearest 10, it would be closer to $10. So if we wanted to estimate the total cost of those two items using rounding to the nearest 10, you'd get a total of $20. Another way is to round to the nearest whole number. So if you took $13.95 and you were going to round it to the nearest whole number, you know it's between $13 and $14, but $13.95 is closest to $14. $8.47, if you're going to round that to the nearest whole number, it's between $8 and $9, but that's actually closer to $8 because it's less than $8.50. Okay, so here, rounding to the nearest whole number, you'd have $14 plus $8, and you'd get a total cost of $22. Now, one thing that I want to share with you is when we're estimating, always show your work, because oftentimes, I might accept a couple of different ways of estimating. If someone was going to round to the nearest 10, I would accept $20. If someone was going to round to the nearest whole number, I would accept $22. But I would need to see your estimates, okay? Now here they're asking us to estimate the difference in the cost of $12.49 and $7.54. We know when we hear the word difference, we're thinking of the operation of subtracting, okay? So if I wanted to estimate, I'd say, well, I think that I'm going to round these to the nearest dollar. So $12.49, I'm going to say that's closest to $12. And $7.54, I'm going to say that's closest to $8. I'm finding the difference, so I'm subtracting. So I would take $12 minus $8, and you would get $4. Okay? And again, I showed my work. That's the critical piece in all of this. When they give you the actual problem to solve, show your estimate right next to it so that we can see how you're thinking. And then, again, sometimes when we're estimating, there might be more than one correct answer.